All right, so there are 5 main types of equations that you can categorize. We're just going to go over the different categories here. So the first one is called a synthesis equation. Sometimes you'll see it written as combination. Synthesis and combination are synonyms, so you can use them interchangeably. Some textbooks use synthesis, some use combination. It's good to know both. Here's some general outlines of what you'll see with synthesis or combination equations. You can have an element making a compound in an element making a compound, or 2 compounds forming another compound. But what you need to see is each one has with it a single compound. So that's what you're going to look for with these. You're going to look for a single compound. It is going to be the only type of equation that has only a single compound. All the rest of them will not. The next one is decomposition. Synthesis and decomposition are exact opposites, you're going to see. So you see synthesis is combining elements and compounds to make a single compound. Decomposition is going to be a single compound breaking down into elements or compounds. So you see here a synthesis, one product that is a compound formed. Decomposition is one compound that is a reactant that is going to break down. So this time you're going to have a single reactant breaking down. Okay, next we have combustion. Combustion is always fire. Whenever you think of combustion, you need to think of fire. You can have a hydrocarbon setting on fire, which is just a combination of C's, carbons, and H's, or you can have a metal that's burning. What I want you to notice is the O2. In order to have fire, you need oxygen. So oxygen, O2, is always going to be your second reactant in a combustion reaction. It could have some kind of compound in an element. It could have a single element metal and a oxygen. But the key is going to be the oxygen is going to be the second element. So what you're going to look for is O2 as second element. The fourth one we're going to look at is single replacement. Single replacement's semi-easy to predict, but sometimes you could confuse it with combustion. Single replacement is always going to be element plus a compound, yielding a compound plus an element. So notice it's element compound on the left, element compound on the right. That's not always going to be true for combustion. Also in combustion, O2 is the second reactant, which is usually not going to happen in a single replacement. So what you want to look for is metals here. This happens a lot with metals. So if you see like a single metal in a compound and then a compound in a single metal, it's probably going to be a single replacement. Next, you see we have the last one, double replacement. This is, again, easy to identify because it's the only one that's going to have 2 compounds to start and 2 compounds to end. There are 3 kind of products that can form from this generally. You can have water, you can have a gas, or you can have something called a precipitate. A precipitate is a solid that forms from 2 clear solutions. So what you're going to have is 2 solutions that look pretty much like water, and then when they combine, they're actually going to make some kind of colored solid substances comes out. And again, you're going to look for with these all compounds. So all I'm going to ask you to do is identify them. So as we start number 23, I think one of the easiest things to do is on the top write what you have. So Li, remember 1 capital letter is an element, and 2, 1 capital letter is an element, and then Li3N, 2 capital letters, is a compound. So if I look back in my notes, an element with a single compound has to be a synthesis reaction. Look at the next one. I have a compound, I have an element, I have a compound and a compound. Could be a little confusing. Don't see that too often, but what I'm going to notice is O2 is a second reactant. In order to have fire, you need oxygen. So this is going to be a combustion. O2 is a second reactant here. Okay, next we have a compound making a compound and an element. Key feature, single reactant. So this is going to be decomposition. Next, we have an element and a compound and an element. I'm noticing that this first element is aluminum, which is a metal. There is no O2 anywhere to be found, so it can't be combustion. So my only choice then would be single replacement. You see sometimes single replacement listed as single displacement. Again, they're synonyms, they mean the same thing. Okay, 27, we have a compound, a compound, a compound, and a compound. The only one with all compounds is double replacement. And again, just like single, sometimes you're going to see double replacement listed as double displacement. That's okay, it's all the same thing. 28, we have a compound, 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 compound. Now here we have all compounds, but you only have a single reactant. Do you see the difference with 27? 27 starts as two compounds, ends as two compounds. So as long as you only have a single reactant, that is going to be decomposition. It is breaking down. And then here we have an element, a compound, and an element. No metal, but also no O2. Can't be combustion. Has to be single replacement.